Welcome to my series 100 Scientists Who Influenced the World, where I've taken a diverse mix of people and broken them down into 10 different categories. There are some famous scientists as well as some lesser known ones, but all of these people have had an influence on the world. Geology is all around us, from the rocks and sand used to make our walls and roads to the minerals found in everyday items. Geologists study the Earth to help improve our understanding of the world around us, the impact we have on it and it has on us. Some geologists have made huge advances in their time, propelling forward our understanding of the world. So who are some of these genius geologists? Clair Patterson. Clair Patterson was born in 1922 in the United States. While he was a graduate student at the University of Chicago, he was tasked with using a newly developed method for measuring the age of the Earth. This involved measuring the amount of lead isotopes contained within rocks. Patterson operated under the assumption that meteorites were formed at the same time as the solar system, so by analysing these rocks, he could determine the age of the Earth. However, he consistently found his samples to be contaminated. He worked hard to remove all possible contamination from his samples, and in 1953 he determined the age of the Earth to be 4.5 billion years old. This number still stands today. Once this task was completed, Patterson returned to the issue of contamination he found in his samples and determined these came from the use of tetraethyl lead in combustion engines, and discovered lead was also used for soldering tins of food shut. He recognised that people would be getting contaminated with lead in the air, and people who worked closely with this substance were also suffering from mental illnesses because of the contamination. Patterson campaigned and took on the petrol industry to have lead removed from the fuels used in motor vehicles. The heads of the petrol companies had a lot of power within the government, and Patterson found this to be an uphill battle, trying to defend the human race from lead contamination against people who were making a lot of money from their use of lead. Eventually in 1970, the Clean Air Act was passed in America, which resulted in the removal of all lead from all petrol in the United States. Reportedly, lead levels within the blood of Americans saw an 80% drop. Arguably, Patterson is one of science's greatest unsung heroes. Inge Lehmann. Inge Lehmann was born in 1988 in Denmark. Her mother was a housewife and her father was an experimental psychologist. As a child, Lehmann was very shy, and this continued through her life. She attended a progressive high school which treated boys and girls equally. The school was run by Niels Bohr's aunt, Hannah Adler, and Lehmann said that her father and Adler were the main influences on her intellectual development. Lehmann started studying chemistry, mathematics and physics at both the University of Copenhagen and the University of Cambridge. However, her studies were regularly put on hold due to ill health. In 1920, she completed her degree in physical sciences and mathematics, then took up a position working at the University of Copenhagen. Lehmann's work in geology began in 1925 when she was responsible for setting up seismic observatories and analysing seismic data. Seismic waves travel at different speeds through different layers of Earth. By monitoring the data of their speed, it is possible to gain clues about Earth's inner mysteries. At the time, scientists believed the Earth had a liquid core surrounded by a solid mantle. In 1929, Lehmann analysed the data from a large earthquake in New Zealand and noticed some seismic waves seemed to be bouncing off a boundary within Earth's core. She went on to publish her theory that Earth's centre consists of a solid inner core surrounded by a liquid outer core. Lehmann went on to discover another boundary within the Earth known as Lehmann discontinuity. Lehmann's work helped change how the Earth is studied. She was also a pioneer for equal rights at a time when there were few opportunities for female scientists. Charles Lyell. Charles Lyell was born in 1797 in Scotland, and at 19 he started studying at Oxford University. Due to the lectures of William Buckland, his interest in geology was stimulated, and he spent the long student holidays travelling and making notes of his geological studies. Lyell completed his bachelor's degree and moved to London to study law, eventually becoming a lawyer in 1925. However, with financial support from his father, Lyell was able to devote more time to geology than law, publishing his first scientific papers and developing new principles of geology. Lyell wanted to communicate that the natural processes and their products of today are not different from those in the past, so therefore the Earth must be very old. In 1830, Lyell published the first volume of his series Principles of Geology, filled with facts and examples. Lyell continued his travels and studies before completing Volume 2 in 1831 and Volume 3 in 1833. The Principles of Geology were so well received that new editions were frequently required, and Lyell continued his geological studies so he could update new editions of his book with the latest ideas and information. Lyell also made important contributions to the explanation of climate change and earthquakes. He was also a friend of Charles Darwin and contributed significantly to Darwin's thinking on the processes involved in evolution. Louis Agassiz. Louis Agassiz was born in 1807 in Switzerland, the son of a Protestant pastor. He attended the universities of Zurich, Heidelberg, Munich and Erlangen, taking on degrees in philosophy and medicine. However, after studying a collection of Brazilian fishes, he became interested in ichthyology, the study of fish. The classification of these fishes was begun by another scientist. However, when they died without completing the work, the collection was passed on to Agassiz to complete the classifications. In 1929, Agassiz became interested in studying fossilised fishes from around Europe and spent a lot of time gathering material wherever he could. He published researches on fossil fishes in which he increased the number of named fish species to more than 1,700, bringing the ancient seas to life again with his work. Agassiz then progressed to studying the fossils of other extinct animals found with the fish and published 2 volumes of work based on his study of echinoderms. Agassiz then shifted his focus to studying glaciers. It had been proposed that glaciers had once been much bigger than observed at the time, and that boulders scattered around the mountains had been moved by glaciers. Agassiz spent time camping on top of a glacier to study it in depth and concluded that at one time Switzerland was completely covered in one big ice sheet. He was the first person to hypothesise that the Earth was once subject to an ice age, something which is now accepted science. Georges Cuvier. Georges Cuvier was born in 1769 in France. His mother eagerly tutored him through his early years and was always the top of his class in mathematics, history and geography. Cuvier was fascinated by natural history, though he proceeded to study comparative anatomy and learned how to dissect animals. He then worked as a tutor and wrote original studies of marine invertebrates before taking up a position at the Museum of Natural History in Paris. Georges Cuvier's first paleontological paper was a comparison of African elephants, Indian elephants, mammoth fossils and unidentified fossil skeletons. Cuvier identified that African and Indian elephants are not the same species, and that mammoths were a third species, meaning they must be extinct. The unknown fossilised skeleton was even more different again. Another study he conducted of a large fossilised skeleton also revealed an extinct animal which was in some way related to sloths. Cuvier then paved the way for evolution to be discovered by changing how animals were classified and raising the questions about why animals are different. By comparing living animals with fossils, Cuvier helped establish the field of paleontology and showed the relation between rock layers and their fossil remains. Alfred Wegener. Alfred Wegener was born in 1880 in Germany, and although he gained a PhD in astronomy, it was really paleoclimatology which interested him, leading to study polar air circulation on Greenland many times between 1906 and 1930. Like many scientists before him, Wegener was fascinated by how much the east coast of South America looked like it could neatly fit together with the west coast of Africa. Wegener gathered together paleontological data on similar fossil finds and geological data on rock layers found on both continents, and concluded that all the land masses on Earth must have previously been joined together in one supercontinent, which he named Pangaea. Other scientists had considered that the land masses had once been joined, however they had concluded that parts of the land had sunk, and that is what created the oceans. What Wegener proposed was different. He suggested that the land masses had gradually moved away from each other over a long time, gradually breaking apart and spreading to different parts of the world. He called this continental displacement. This position was not accepted by most geologists, and Wegener died in 1930 on his last expedition to Greenland, with his theory widely rejected. However, in the 1960s it was revived as part of the theory of plate tectonics and is now known as continental drift, a widely accepted theory. James Hutton. James Hutton was born in 1726 in Scotland and was one of 5 children. He was educated in Edinburgh, where he was particularly interested in mathematics and chemistry. He was a student of humanity at the University of Edinburgh and then achieved a doctorate in medicine from the University of Leiden in the Netherlands. Hutton returned to Scotland and set about making improvements to the farming practices of the farm he had inherited from his father. This developed his interest in meteorology and geology, and he became very fond of studying the surface of the earth and analysing the rocks as he was doing work on the farm. This is when his theoretical ideas started to develop, and he would go off on field studies around Scotland. Hutton published his Theory of the Earth in 1788, which was increased to 2 volumes in 1795, presenting his findings about how the process of erosion, deposition and uplift of rocks were connected and operated continuously, driven by the Earth's internal heat. This idea had never previously been understood, however Hutton brought it to light, changing how geologists study the Earth and becoming known as the father of modern geology in the process. Florence Bascom. Florence Bascom was born in 1862 in the United States. Her family were unusual for the time, as her parents were strong supporters of women's rights and encouraged women to be part of society and obtain a college education. Bascom's father was the president of the University of Wisconsin and was her first contact with geology. Bascom received 2 bachelor's degrees and a master's degree from the University of Wisconsin before completing her PhD in geology from Johns Hopkins University, making her only the second woman to earn a PhD in geology in the United States and the first to do so from Johns Hopkins University, though when she attended classes she had to sit behind a screen in the corner of the room. Bascom was then employed by the United States Geological Society, the first woman ever hired by this scientific agency, while also teaching at Bryn Mawr University. Bascom studied the Piedmont region, a vast plateau that lies between the Atlantic coast and the Appalachian Mountains, becoming an authority on the formation, rock structures and cycles of erosion in that region, collecting large amounts of data. Bascom retired from Bryn Mawr University in 1928, and in 1936 she retired from the USGS. It's difficult to determine whether her greatest legacy is the amount of scientific data she collected, analysed and mapped, which is still referenced by scientists today, or if her legacy is in the number of women she steered into STEM and geology in particular, carving a path for future women to follow. Eugene Shoemaker. Eugene Shoemaker was born in 1928 in the United States. As a child he moved around a lot of different places as his dad moved from job to job. While his mother was teaching in Buffalo, Shoemaker's interest in studying rocks was ignited by the science education courses offered by the Buffalo Museum of Education. In 1948, aged 19, Shoemaker earned his bachelor's degree and received his master's degree a year later. Shoemaker was employed by the United States Geological Survey and set about studying volcanic processes, exploring a region near Meteor Crater in northern Arizona. Daniel Barringer, who had discovered Meteor Crater in 1891, had suggested that it had been caused by a meteor impact. However, the chief geologist of the USGS, G.K. Gilbert, said it was caused by explosive venting of volcanic steam, and most scientists agreed with this position. In 1960, however, Shoemaker, along with Edward Chow, identified shocked quartz at Meteor Crater. This proved it was formed by a meteor impact. Shoemaker then worked with the USGS to generate the first geologic map of the moon using photographs, helping to found the field of astrogeology in the process. Shoemaker also discovered comet Shoemaker-Levy 9, which turned out to be unique as it provided the first opportunity to observe a comet impact a planet when it collided with Jupiter in 1994. This impact caused a scar on the face of Jupiter. Charles Richter. Charles Richter was born in 1900 in the United States. Richter's parents divorced when he was young, so he grew up with his mother and grandfather. After receiving a degree from Stanford University, he began working on a PhD in theoretical physics from the California Institute of Technology. However, he did not complete this, instead taking a job as a research assistant where he became fascinated with seismology, the study of earthquakes. Richter took a position at the Seismological Laboratory under the direction of Benno Gutenberg. At this time, the California Institute of Technology wanted to begin publishing regular reports about earthquakes and needed a way to measure the strength of earthquakes for their reports. Together, Richter and Gutenberg devised what would become known as the Richter scale to measure the force of an earthquake. This was based on measurements from a seismometer 62 miles, 100 kilometres from the earthquake. From 1935, the Richter scale was what was used around the world for quantifying the size of earthquakes. In 1979, the moment magnitude scale was developed and replaced the use of the Richter scale. Despite there being a difference in the two scales and the MMS being the one that is used, some reports still say Richter scale even though the MMS is the scale used. Thank you for watching this video in my series 100 Scientists Who Influenced the World. The majority of the information for this video came from the books 100 Scientists Who Made History and the Britannica Guide to the 100 Most Influential Scientists, as well as some other sources from across the internet. If you liked this video, please hit the like and subscribe buttons, and be sure to check out my other videos such as my STEM experiment and explanation videos, my robotics videos and my STEM career interviews. This has been STEM with Mr. N's 100 Scientists Who Influenced the World, Genius Geologists.